Hi, and welcome to our presentation on hormone-dependent breast cancer. Hormone-dependent breast cancer is the most common type of breast cancer that is diagnosed today. It is a type of cancer where the cancer cells rely on the body's naturally produced hormones, estrogen and progesterone, to survive and reproduce. Did you know about 75% of breast cancers are ER positive, estrogen receptor positive, and about 65% are progesterone receptor positive? Breast cancer tumors that are ER and PR positive are 60% more likely to respond to endocrine treatment. HTBC is common and treatable. There are four main classes of treatments for HTBC. These include selective estrogen receptor modulators, SERMs, aromatic inhibitors, biological response receptors, luteinizing hormone releasing hormone agents. SERMs mimic estrogen receptors and also bind to breast cancer cells. Aromatase inhibitors prevent the production of estrogen in adrenal glands. These are used in postmenopausal HTBC. Biological response receptors work by binding with certain proteins of breast cancer cells, thus preventing their growth. Luteinizing hormone-releasing hormone agents shut down the ovaries to prevent them from producing estrogen. Tamoxifen is a type of SERM and is the most widely used for drug treatment of HTBC. It is a non-steroidal agent. It is cytostatic. This means it prevents cancer cells from dividing or replicating, but it doesn't cause cell death. Tamoxifen is also used in pre-cancer treatment. It is used in both early and advanced stages of breast cancers. It has recently been FDA approved for use in postmenopausal women at a high risk of breast cancer. This was due to a clinical trial which proved tamoxifen can reduce the risk of breast cancer by 49%. Tamoxifen is an organic compound belonging to the stilbene family. Stilbenes are compounds which contain 1,2-diphenylethylene in their structure. As you can see, these substituents are organonitrogen, include organonitrogen, tertiary amine, alkyl aryl ether, phenylpropene, and so on. It's classed as a small molecule with a molecular weight of 371.2 grams per mole. Tamoxifen does not have any hydrogen bond donors, but it has two hydrogen bond acceptors. Its rotatable bond count is 8 and its polar surface area is 12.5 angstroms squared. The drug does not obey Lipinski's rule 5, which is the rule that evaluated chemical compound properties that would make it likely orally active drug in humans. The rule which does not obey is that the log P value is greater than 5. However, nowadays this rule isn't highly thought of. Did you know tamoxifen is also being used to treat mania and bipolar disorder by blocking protein kinase C? This is an enzyme that regulates neuron activity in the brain. Now for the mode of action. Here, these pictures show details of the tamoxifen binding to estrogen receptors. Pharmacodynamics is explained as follows. An active metabolite tamoxifen called 4-hydroxytamoxifen binds to estrogen receptors to form a complex. This complex picks up co-repressors, which are proteins, and binds to DNA to modulate gene expression. These metabolites bind to estrogen receptors competitively in the tumor cells. DNA synthesis is lowered and inhibits estrogen receptors. The overall outcome is that the cancer cells die because they can no longer bind to the receptor sites. Tamoxifen is a prodrug, therefore it has little affinity for the estrogen receptor. The liver metabolizes the drug by cytochrome P450. It is metabolized into two active metabolites, N-desmethyl-4-hydroxytamoxifen and 4-hydroxytamoxifen. Both of these are active metabolites and have 330 to 100 more times affinity with estrogen receptors than tamoxifen itself. The 4-hydroxytamoxifen metabolite is most important in HTBC, as it is an estrogen receptor antagonist. Tamoxifen is administered orally. It reaches a steady state of concentration within 4 weeks of its first administration. To conclude, tamoxifen is an extremely effective drug used to treat hormone-dependent breast cancer. Thank you for listening. Any questions?
Created using Powtoon.